Hi everybody, Miss Richmond here, and today we're going to be working on equivalency using multiplicative relationships. You should have already watched the video that went over how to use multiplicative relationships, but before we get started with our guided practice, I want us to review really quickly our simplifying fractions exit ticket from yesterday. So yesterday we were using the greatest common factor to divide the numerator and the denominator. And so to find the greatest common factor, we're going to list our factors of both the numerator and the denominator. So for 8 and 10, the factors of 8 are 1, 2, 4, and 8. The factors of 10 are 1, 2, 5, and 10. We notice that we have a 1 as a common factor and we have a 2 as a common factor. That means that we can divide both the 8 and the 10 by 2. Now, what that's going to look like is we're going to have 10 circles. 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 circles. 8 of them will be shaded. And dividing by the greatest common factor means that you are going to be circling groups of 2. So that's what we're going to be doing, is we're going to divide our 8 by 2 and we're going to divide that 10 by 2. So we're going to circle groups of 2. So that's 1 group, 2 groups, 3 groups, 4 groups, and 5 groups. Now, this model will show you that 8 divided by 2 is 4, and that 10 divided by 2 is 5. And so we're going to actually use this understanding of being able to divide both the numerator and the denominator by a common factor, in this case the greatest common factor, to simplify, will help us be able to create equal fractions. So the guided practice that I'm going to be going over is on page 519 and 520 in your textbook. So the first problem, you're given 2/3, and the textbook wants you to multiply both the numerator and the denominator by 3. So we can say that 2 times 3 is 6, and we can say that 3 times 3 is 9. And because we're multiplying both the numerator and the denominator by the same factor, we are able to know that 2/3 is equivalent to 6/9. Now in number 2, instead of multiplying, we're going to be dividing. So we can say that since 5 is a factor of both 5 and 10, we're able to divide both the numerator and the denominator by 5. Well, 5 divided by 5 is 1, and 10 divided by 5 is 2. So I can know that 5/10 is equivalent to 1/2. Sometimes, however, instead of having to multiply both the numerator and the denominator in order to find an equivalent fraction, you're given part of an equivalent fraction and you're trying to find that missing part. So in this case, what you want to do is you want to look at the relationship between the known parts and use that same relationship with the unknown parts. So in number 3, what this means is that I know that 6 times some number is going to give me 12. Do you know what number that is? That's right, 6 times 2 is equal to 12. And therefore, since I'm multiplying my denominator by 2, I need to go ahead and multiply my numerator by 2 as well. So 5 times 2 is 10. Since the relationship between the numerator and the denominator is the same, and this is what we're talking about when we say the relationship, it's what you're multiplying by both the numerator and the denominator, we know that they are equivalent fractions. Let's try number 4 on our own. Pause the video for a minute and give it a go. How did it go? Were you able to see that 10, this time since we're getting a smaller number, we're going to need to divide. In this case, instead of multiplying by 2, we need to divide by 2. Since 10 divided by 2 is 5, I need to divide 12 by 2, and that will give me 12 divided by 2 is, that's right, 6. Let's try number 5 and number 6. Pause the video, see if you can do them on your own. Were you able to see that 12 divided by 3 is equal to 4? So that's what I'm going to do to my numerator as well. 3 divided by 3, because that's the relationship that we're looking for here. 3 divided by 3 is 1. So I know that 3/12 is going to be equal or equivalent to 1/4. Did you try out number 6? Did you know that 3 times 3 is equal to 9? Were you able to figure that part out? And since I'm multiplying my numerator times 3, I'm also going to multiply my denominator times 3. And 4 times 3 is 12. Did you try number 7? Since my relationship from the denominator that I am given to the next denominator I'm getting smaller, that means I'm going to be dividing. So 12, I know, divided by 3 is equal to 4. So what number divided by 3 will equal 3? You guessed it, it's 9. 9 divided by 3 gives us 3. In number 8, the question is asking us to think about how if Josh, Lisa, and Vicky all eat 1/2 of their pizza, so all of them are going to eat 1/2. Josh only ate 1 slice, but Lisa, when she ate her pizza, she was able to eat 3 slices for her 1/2, and Vicky was able to eat 4 slices for her 1/2. How is this possible that they each ate half of their pizza, but they ate different numbers of slices? Well, as we've been learning, we can rename fractions in lots of different ways. We know that 1/2 is equal to 3. Do you know what that denominator is? 3 out of, you guessed it, 6, because 1 times 3 is 3, and 2 times 3 is 6. We can also know that 1/2 is equal to 4 out of, that's right, 4/8, because 1 times 4 is equal to 4, and 2 times 4 is equal to 8. So 1/2 can also be rewritten as 3/6 and as 4/8. Remember, it's very important that you understand that whatever you do to the top, you have to do to the bottom. That's the relationship. Being able to multiply or divide your numerator and your denominator by the same factor is the relationship between those two equivalent fractions. Good luck on your exit ticket.